Now we're going to look at doing SOHCAHTOA right angle triangle problems, but we're going to have two triangles in all of our problems. So let's take a look at what this might look like. It says find AB to the nearest tenth of a meter. So AB is this, right? So what's going to happen is, in all of these questions with these two right angle triangles, what's going to happen is they're going to give you enough information in one triangle to find something in common with the other triangle, and then you'll have enough information in this triangle to solve what you're looking for. So what part of these two triangles is the same? Clearly this side, AC. So if we want to find the length of AC in triangle ADC, we know we start at the angle. What we're looking for is opposite. What we're given is adjacent. So we're looking at, you probably know this before I even write out SOHCAHTOA, but opposite and adjacent is of course tan. So we've got the tan of 35 is equal to, let's call that letter D, because it's opposite D, over 54. Then we're going to cross multiply, so D equals 54 times tan of 35 degrees. Okay, let's see what that equals. So that equals 25.5859 yada-da. So D equals about tenth of a meter. So we're going to do a tenth, so that's 25.6. Now, if this is 25.6, and this angle we know, and this angle we're given, in this triangle now, we know we have, I'm just going to write it again here, we know this is a right angle, we know this is 20 degrees, we know this is what we're looking for, I'll call it C, and this is 25.6. So from the angle, what we're looking for is opposite, what we're given is adjacent, so it's tan again, so tan of 20 degrees equals opposite over adjacent, cross multiply, so we have C equals 25.6 tan 20 degrees, and then we just multiply it all out, 25.6 approximately, and it is approximately 9.3. So what's the question? Find AB to the nearest tenth of the meter. Therefore, AB is about or approximately, right? I have to use about or approximately 9.3 meters. Okay, let's take a look. Remember, you're given enough information here to find something in common, and then use that with the rest of the information to find what you're looking for. Confederation Bridge spans the Northumberland Strait, joining New Brunswick and Prince Edward Island. From one point on the strait, the angle of elevation to the highest point on the bridge is 27 degrees. From a point 100 meters closer to the bridge, the angle of elevation is the angle of elevation is 73 degrees. And here's the bridge. How high is the bridge to the nearest meter? So, obviously, I'm far more comfortable than you are drawing diagrams, but you've got to start with what you've got, and what you've got is who you are today, so let's just do what we can. Again, you just draw it out as, you see how I really dissected the words, and every time there was something I even drew part of a diagram? You're just going to have to, you learn by doing. This is how things work. You learn by doing. It's why we do math in pencil, so you just keep on going until you are able to comfortably draw these triangles. So we want to know how high this is. Now this is, of course, like I said, bridges will meet the ground at 90 degrees and whatnot. And we have two triangles here. I'm just going to call it A, B, C, and D. We have triangle ACD is a right angle triangle, and BCD. So let's take a look here. And then we have this triangle here, ABD, which is not a right angle triangle, which we haven't learned to do those kind of problems yet, but we will in a few lessons. Now this distance here, it's opposite D, so I'm gonna call it D, okay? So in the little triangle, I'm gonna say that these two sides are opposite and adjacent. So the tan of 73 is equal to H over D. And then in the big triangle, this is opposite and this is adjacent to 27. And this big triangle looks like this. This whole side is 100 plus D, right? So I've got tan of 27 equals H over 100 plus D. So you might be thinking, what am I supposed to do with this? Oh my gosh. Well, let's figure this out. First thing I want you to do is I want you to find out what H equals here and what H equals here. So here, we know when we cross multiply, we have H equals D times that. So H equals D times tan 73. Here, we know that H is equal to this times that. So H equals 100 plus D times tan 27. There we go. So now if H equals this and H equals this, don't those then equal each other? Of course they do. All right, well, let's see what we can do here, okay? We've got H equals this, and H equals this. So think of it this way. I'm just going to write here for an example. If we have that 6 equals 5 plus 1 and 6 equals 8 minus 2, can't we therefore write that 5 plus 1 equals 8 minus 2 because they both equal 6? And you know that does equal that, right? So what we're going to do here is that sort of concept. If H equals all of this and H equals all of this, then let's solve and let this equal this. So that means we're going to let D tan 73 equal 100 plus D tan 27. I'm then going to distribute this out. So we have D tan 73 equals 100 tan 27, plus D tan 27. Then I'm going to collect my D's. So I've got here D tan 73 minus D tan 27. And I'm going to leave this here on the right side. Now I'm going to common factor out D. So I've got D tan 73 minus tan 27 equals this. And then I have a big version of this. I have something times something equals something else. So what I'm going to do is I'm going to divide both sides by whatever is in front of my variable, or whatever my variable is multiplied by. So here I have D times this big thing, which I can just punch in my calculator and find a number, equals this. So I'm going to divide both sides by this. So what I'm going to have, I'm going to go back up over here, is I'm going to have D equals this over all of that. So I've got 110, 27 all over this minus this. And now I have to punch it into my calculator. So let's see, what do I have here? So remember, not difficult, but long. This is not difficult. You're doing exactly what you've done before, just bigger numbers and it's busier. But the concepts are all the same. So I've got here, my numerator is equal to, wait a minute, I did something not right. 1 second. So my numerator is equal to about 50.95, blah, 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 blah. And my denominator is equal to, hang on, let me just erase this for a second. Approximately this minus actually I did the whole thing, hold on. The whole thing is equal to about this. And when I divide this by this, well, first of all, that's about 50 and that's about 2. So I know I'm going to be around 25, but let's just see. Divided by, I get, oh, actually, this is actually more like closer to 3 divided into 50. So I get about 18.45. 18.45219411942588, and then I don't see any more on my calculator screen. Now, did I answer the question? Well, I don't know. I got to reread it. I can't even remember now. So, how high is the bridge? We don't know how high the bridge is. We now know what this distance is. But that's okay because we know what D is, and we can just plug it into here and find out what H is. So let's multiply that by the tan of 73, and what do we get? Hang on, I just erased my calculator accidentally, 1 second. So tan of 73 times is about 60. So, okay, we're really running out of room. I'm just going to write it right up here. H equals 18.45 times tan 73 because of that. And that equals about 60 to the nearest meter. 60. I got 60.34, yada, yada, yada. So how high is the bridge? I'm just going to squeeze in my answer here. Therefore, the bridge is about, because we rounded, 60 meters high. I should answer 60 meters high. Okay, so that's what 2 triangle questions look like. Here is another one we're going to do right now. 2 buildings are 14.7 meters apart. From the top of one building, the angles of depression to the top and bottom of the second building are that and that. Find the heights of the buildings, both of them, to the nearest tenth of the meter. So we've got a building here and a building here. And they are 14.7 meters apart. From the top of one building, the angle of depression to the top and the angle of depression to the bottom, don't forget that's from the horizontal down, are going to be here 27.5 and here 63.8. Find the heights of the buildings. I've got to draw this diagram again. This is way too squishy for me. So here I've got this, and I know I'm going to the top of a building and the bottom of a building. And here is, I'm going to call this building 1, and this is building 2. Oh, wait a minute. This is the top of the building, and this is the bottom of building 2, and this is the top of building 1. Let me see if I've got this right. Two buildings are 14.7 meters apart. So as you can see, if you need to draw the diagram twice, you do. Once to sort of think it through like I did, and then another time to really see what's going on and use the diagram. So, two buildings are 14.7 meters apart. From the top of one building, the angle of depression to the top is 27.5, and the angle of depression from there to there to the bottom is 63.8 degrees. Find, I'll call that height, and I'll call that, I don't know, height 1 and height 2. Oh, what am I doing? I should call that height 1 and that height 2, because that's building 1 and building 2. Okay, so are you able to see what's going on yet? If not, then let's draw it again without the buildings. We've got height 1 that we need to find out. We've got, this is 14.7. This is height 2. From here to here, we don't know what the length is, but what we do know is that this angle is 27.5. We also know that if that's 27.5, then this is 90 minus 27.5. And then here, from here to here, if we know that this is 63.8, then we know that this is 90 minus 63.8. So 90 minus 63 is 26.2. And 90 minus 27.5 is going to be, what's that, 70, 60, what am I saying, 62.5. Okay, so now I have triangle with this. So again, you're going to find that you're going to be able to go from here right to where I'm going now. But if you need to sort of think it through in steps, I'm showing you all the steps that you could use. You don't need to use them all. So here in our first triangle, we have, this is going to be height 1. This is going to be 90 degrees. This is going to be 26.2. And this is going to be 14.7. So we have enough to find out height 1 in this triangle. Okay? When we find out this length, we will then know this length here and be able to do something with that. So let's start with this. So this is opposite this and adjacent this. So we have the tan of 26.2 degrees equals opposite over adjacent. And then we cross multiply, so we have that H1 equals 14.7 over tan 26.2. And we need to then put it in the calculator. And we're rounding everything to the nearest tenth of a meter. So we've got 26.2 is what we're taking the tan of. And then we've got 14.7 divided by that tan 26.2, which equals 29.87. or 29.9. So equals about 29.9 meters. Okay, so now that we have that, that's the height of the first building. The height of the second building, just trying to get some space in here. The height of the second building we now need to sort out from this diagram. So as you can see, the height of the second building is not the side of a right angle triangle, but we just dealt with this before where we had this height or length and then we called this, let's say, x. So we know here that if we can find this x, we know that the first height is the same as the second height plus x. So why don't we find out what x is, subtract it from here, and then we'll end up with this. Okay, let's do it. So we've got here in our second triangle here, we've got this distance is 14.7. This angle is 27.5. So I did this thinking I might use it. It ended up I didn't. Doesn't matter. You're on inquiry investigation. You write down what you can think of and you use what you need to. And then this length is x, and that's a right angle. So this is opposite and this is adjacent. So we have a tan situation again. Tan 27 equals x over 14.7. So x equals 14.7 times tan 27.5, and that whole thing equals 7.5, 10, oops, 1 second, times 14.7, and that whole thing equals about 7.6. So now we know that H2 is equal to 29.9 minus 7.6, which is 22.2, well, 22.3 actually, 22.3, about 22.3. And now we have to write our answer. Boy, I really use that space, huh? Okay, so our answer I'm going to write way up here. Therefore, the two buildings are about 29.9 meters and 22.3. So as you can see, people use this in construction, they use this in all sorts of things. And even if they're not anymore, all the devices that people are using in their jobs to do these things are programmed by people who know how to use this and write programs using all of this so that the machines can work. Okay, there we go. Word problems with two